Fixed point iteration method. Fixed point iteration method is open and simple method for finding real root of nonlinear equation by successive approximation. It requires only one initial guess to start. Since it is open method, its convergence is not guaranteed. The idea of the fixed point iteration methods is to first reformulate given equation to an equivalent fixed point problem. So fixed point iteration method is open method. It means root will not be bracketed. There are two kinds of methods. One is open methods and the other is bracketing methods. So in bracketing method, the root always lies within the interval or within two values. But in open method, method, it is not necessary to bracket the roots. So that is why we can say that it is not guaranteed that root must lies within two values or bracketing the roots. So the convergence of this method is not necessary. Sometime it can converge and sometime it may not converge. It depends on the reformulation of the given function. So the first and very necessary step of this method is that we must have to write the given function in the form of x is equal to g of x. So which is the form of correct by which the derivatives is derivative have some important value. For example, its derivative should be less than 1, then we will say that this form is a good form of x is equal to g of x. So in the definition, a fixed point of a function g of x is a real number p. A fixed point of a function g of x is a real number p such that p is equal to g of p. So we can just say that a point is a fixed point when we substitute instead of x, it will not change its value. Then p is called the fixed point. For example, if f of x is equal to x square minus 2 and we replace x with x is equal to 2, so and we can also replace x is equal to minus 1, we will get the same values. For example, if we replace x with 2, we will get 4 here and 4 minus 2 will again be equal to 2. If we replace x with minus 1, this will be 1 and minus 2 plus 1 equal to minus 1. So these 2 points are fixed points of f of x. So note that fixed point is a number at which value of the function does not change if the function is applied to that number. So we can define the fixed point as a value of the function. It does not change if the function is applied to that number. Okay. Next, we can write the steps in the form of algorithm to find the real root of nonlinear equation f of x is equal to 0. Using fixed point iteration method, the following steps are carried out. Number 1, determine the interval on which the function has opposite signs. Determine the interval on which function has opposite signs. So here we can get a rough estimate that what is the interval where the given function has opposite signs. So it means the given function has root within that range. Set the convergence parameter. We need to define that how much degree of accuracy you need to how much decimal places you need a correct answer. If we are given that find answer correct up to 3 decimal places, it means the value of our epsilon is should be equal to 0.000123. So determine new function x is equal to g of x by rearranging nonlinear equation f of x equal to 0. This is the third step. The fourth step is that if x is equal to g of x, so if it has more than one forms, then we must have to select g prime x absolute value less than 1. And number 5 is apply the fixed point iteration xn plus 1 is equal to gn of x. If xn plus 1 minus xn absolute value less than or equal to epsilon, then xn plus 1 is fixed point and xn plus 1 is the root of nonlinear equation. F of x is equal to 0. Otherwise, go to step 4. So these are the steps which we must have to carry out to estimate the root of the function. Next is the example which will illustrate how can compute. Find a real root of the following nonlinear equation using fixed point iteration. So this is the equation for which we have to compute the fixed point iteration x4 minus 4x cubed plus 6x squared minus 2.25 equals 0. Proceed as follows. F of x is equal to x squared minus 4x cubed plus 6x squared minus 2.25. So if we substitute x with 0, we will get this 0, 0, 0 minus 2.25. So minus 2.25 is a negative value which is less than 0. And if we replace x with 1, that is f of 1 is equal to 1 minus 4 plus 6. So that is 0.75, which is greater than 0. So it means our rough estimate of the root is 0 and 1, and root will lie in between 0 and 1. Therefore, root lies in the interval 0 and 1. Rearranging given function, if we rearrange the given function, so we have many choices. For example, we can just substitute this x4 on the left side, and also we can replace 4x cube on the left side. Also we can replace 6x square on the left side. So there are three obvious choices and also many other choices. So if we replace x4 on the left side, and we can write x is equal to g of x as 4x cube minus 6x square plus 2.25 whole power 1 by 4. And then if we differentiate the given function, we'll get the form 1 by 4 cube minus 6x square, or this should be 4x cube, not 4 cube, 4x cube, 6x square plus 2.25 minus 3 by 4 as a power, and then 12x square minus 12x. So g prime of x is equal to 3x square minus 4, this one 3, because 4 will divide 12. So 4 3s are 12, 4 3s are 12, and we can write out this 3 into x square minus x. 4x cube minus 6x square plus 2.25 whole power minus 3 by 4. Since g prime of 0 is equal to g prime of 1 equal to 0. So if we substitute 0 here, you will get the value less than 1, and if you substitute 1, you will get the value less than 1. These are the boundary points of the interval 0 and 1, because you have said that the root will lie in the interval 0 and 1. So we substitute 0 and 1. Therefore, apply iteration formula of fixed point xn plus 1 is equal to g of xn, that is xn plus 1 is equal to 4xn cube minus 6xn square plus 2.25 whole power 1 by 4. Compute first iteration by setting n is equal to 0. Equation 2.5 will take the form as x1 4x naught cube minus 6x naught square plus 2.251 by 4. Taking x naught is equal to 0.75, as it is very close to 0 in the interval 0, 1, for f of 0 is equal to minus 2.25 less than 0. So we can take x naught as the initial guess, because it is close to 0 in the interval 0, 1. So it's up to you. You can take 0.5, 0.25, 0.3. So if we take this as an initial guess, so x1 will be 4 into 0.756 into 0.75 plus 2.25 all power 1 by 4, and we will have the first iteration as x1 is equal to 0.8659. Also for n is equal to 0, xn plus 1 minus xn will be x1 minus x naught equal to 0.1159. So to compute second iteration, set n is equal to 1, it will give x2 is equal to 4x1 cube minus 6x1 square plus 2.25 whole power 1 by 4. So x2 is equal to 4 into, we will just replace x with 0.8659, and we will get x2 is equal to 0.7681. And for n is equal to 1, we have this values x2 minus x1 is equal to minus 0.0978. Absolute value will be equal to 0.0978. So this is actually the value of the epsilon. So we are just guessing that what will be the epsilon, or what should be the halting condition. To compute third iteration, set n is equal to 2, it will give x3 is equal to 4x square cube minus 6x square plus 2.25 whole 1 by 4. X cube is equal to this one 1 by 4 equal to 0.8503. Also for n is equal to 2, x cube minus x square is equal to 0.0822. So similarly, if we continue to compute this iteration, we will get x4 is equal to 0.7804, 0.8396, 0.7891, and we compute the differences, we will get this difference minus 0.03927. So here we can say that we are just near to the root. Maybe we need some more iterations to get the good root, because here the epsilon is just 0.004 or zero 0.05, because 0.039 can be set as less than epsilon, where epsilon is 0.04 or 5. So you can see that root is not converging very rapidly. Next, the theorem is that assume that G is continuous function, and that sequence of the roots P1, P2, P3, so on Pn is a sequence generated by fixed point iteration. So if Pn limit n approaches to 0, Pn is equal to P, then P is a fixed point of g of x. So how we can say that P is a fixed point? So if we have a sequence of roots and this sequence is converged to a fixed number or to any number, then this number will be called as the fixed point. Suppose that limit n approaches to infinite Pn is equal to P, limit n approaches to infinite Pn plus 1 is equal to P. Then consider the fixed point iteration. Pn plus 1 is equal to g of Pn, and taking limit on both sides, this will have limit n approaches to infinite Pn plus 1 is equal to limit n approaches to g of Pn. As g is continuous, so P is equal to g of limit n approaches to infinite Pn. So P is equal to g of P. Hence P is a fixed point of Gp. So it's not very difficult. Just you rewrite the formula of fixed point iteration, apply the limit on both sides, and then apply the limit on P of n. And since Pn will converge to P, so here Pn converge to P, we replace left side with the right side and we will get the answer. Remark is there, given a root finding problem f of p is equal to 0, we can define a function g with a fixed point at p in a number of ways. For example, as g of x is equal to x minus f of x. Conversely, if the function g has a fixed point at p, then the function defined by f of x is equal to x minus g of x has a 0 at p. So given a root finding problem, f of p is equal to 0, we can define a function g with a fixed point at p in a number of ways. So there are many ways to redefine the function. For example, it's simply g of x can be written as x minus f of x. And conversely, if the function has a fixed point at p, then the function defined by has a 0 at p. So theorem, sum of the results, uniqueness of a fixed point. If G belong to C of AB, that is the a set of continuous function over AB, and G of X belong to AB, then G has at least one fixed point in AB. So what's the main point is to keep in mind that if we are finding this root by iterative procedure, then the given function must be continuous. For example, in the fixed bisection method, function must be continuous. In the regular falsy method, function must be continuous. But for the Newton method, function must be continuous and differentiable. So the condition of continuity is for all functions to which we are applying these iterative procedures for finding these roots. Moreover, if g prime of x means this derivative of function exists on AB and a positive constant k less than 1 exists with this derivative, absolute value of derivative of the function should be less than or equal to k for all x belong to AB. Then there exists exactly one fixed point in the interval AB. So if we are interested to find only one fixed point, then the function must have the following conditions. What kind of conditions? Number one, the function must be continuous. Number two, for any k less than epsilon, the derivative of the function must be less than or equal to k. So that is the condition. We can simplify to keep in mind that if we are interested to find only one fixed point, or we are interested to know whether the function has one fixed point or more than one. So if the function will satisfy these two conditions, the function will have only one fixed point. So what are the conditions? Function should be continuous. Number two, that if the k is less than 1, so for derivative of the function, absolute value of the derivative will be less than or equal to k. So this assertion can be proved as follows. If g of a is equal to a or g of b is equal to b, then g has fixed point at an end point. Suppose not, then it must true that g of a greater than a. One of you can take the attendance and send me, please, because we are maybe the meeting will be end, and then you just re-click on the same link and we will rejoin. G of a greater than a and g of b less than 0 b. The function h of x equal to g of x minus x is continuous on ab. So this is actually the rearrangement of the given function. So if the given function is g of x, so you can suppose one of the rearrangement of the function is g of x minus x, and you call it h of x. So then substitute the first boundary point, which is a. So h of a is equal to g of a minus a. So it should be greater than 0 if the function has a root within the interval ab. And on the other side, if we substitute the other boundary values b, h of b equal to g of b minus b, so it should be less than 0, negative. So that is why the intermediate value theorem is showing that there is exist a root. So intermediate value theorem implies that there exists P belong to AB for which h of P is equal to 0. For this value of P, h of P is equal to g of P minus P equal to 0, and this implies g of P is equal to P or P is equal to g of P, which shows that P is a fixed point of G. And next, for the second condition, suppose in addition that the absolute value of the derivative of g of x less than or equal to k less than 1, and that p and q are both fixed point in AB, with p is not equal to q by means value theorem. There exists a number mu between p and q and hence in interval AB with derivative g prime of u is equal to g of p minus g of q over p minus q. So p minus q absolute value can be written as g of p minus g of q is equal to p minus q absolute into g prime of u. After simplification, we can get this, that p minus q implies p minus q and less than p minus q. This contradiction must come from the only supposition that p is not q. So hence p is equal to q and the fixed point in the interval is unique. So next is the order of convergence. Suppose we have a sequence of the roots is a sequence converges to p with pn is not equal to p for all n. If a positive constant lambda and alpha exist such that limit n approaches to infinite, Pn plus 1 minus P absolute over Pn minus P power alpha is equal to lambda, then Pn is linearly convergent if alpha is equal to 1. and Pn is quadratically convergent if alpha is equal to 2. So here we can find whether the given function is linearly convergent or quadratically convergent. So if Pn plus 1 minus P over Pn plus minus 1, so we just have to find this alpha. If alpha is equal to 1, then we say that the given function is linearly convergent. And if alpha is equal to 2, we say that the given function is quadratically convergent. So convergence of a fixed point iteration. So we can talk about this convergence also. Let the equation to be solved f of x equal to 0 we can be written as x is equal to g of x and x is equal to a will be the exact root of f of x equal to 0. Further assume that x1, x2, so on xn plus 1 are the approximation of the exact root determined from the fixed point iterative formula. That is x1 is equal to g of x naught, so xn plus 1 is equal to g of xn. Let epsilon n and epsilon n plus 1 be the values of errors at nth and n plus 1th approximation respectively. That is epsilon n is equal to a minus xn and epsilon n plus 1 a minus xn. So a minus epsilon n plus 1 can be written as g of a minus epsilon n. Since epsilon n is a small quantity, so the function g can be expanded about a minus epsilon n. Using Taylor series expansion, a minus epsilon n plus 1 can be written as g of a minus epsilon n g prime of a plus epsilon n square over 2 factorial g double prime of a. And we can simplify as epsilon n plus 1 is equal to epsilon n g prime of a minus epsilon n square over 2 factorial plus so on. Since epsilon n is a small quantity, so the terms involving epsilon n square and its higher powers can be neglected as epsilon n plus 1 is equal to epsilon n g prime of a. And epsilon n plus 1 over epsilon n is equal to g prime of a. It can be concluded that fixed point iterative formula is linearly convergent because here alpha is equal to 1. As alpha is equal to 1, so it is linearly convergent. It can also be concluded that the sequence generated by fixed point iterative formula will be convergent if absolute value of the derivative less than 1, that is absolute value of epsilon n plus 1 less than epsilon n, which is a convergence criteria. So we can revise this whole lecture. Okay. Fixed point iteration procedure or iteration method. So fixed point iteration method is open and simple method for finding real root of nonlinear equation by successive approximation. It requires only one initial guess to start. Since it is open method, its convergence is not guaranteed. The idea of the fixed point iteration methods is to first reformulate given equation to an equivalent fixed point problem. So there is nothing difficult to explain, but just to remember that fixed point method is an open method but not a bracketing method, and is a simple method to finding the real root of nonlinear equation by successive approximation. So it requires only one initial guess as compared to the secant method, because secant method require two initial guess. Okay. Since it is open method mean it is not a bracketing method. So that is why its convergence is not necessarily uh, guaranteed. Sometimes it converges and sometimes it may not converge. So it depends on the reformulation of the given function. What is the definition of the fixed point? A fixed point of a function is a real number such that if we substitute this real number with the function, so then the value of the function should be equal to this number. So then this number is called the fixed point.